Course 3 Module 3 Managing Budgeting and Procurement. Introduction, Managing Budgeting and Procurement. Budgeting in Project Management. Importance of procurement in project management. Vendor management in Agile versus traditional methodologies. Legal and contractual documentation, NDAs, RFPs, SoWs, role of legal teams and ethics in procurement. Creating your own documentation using templates. Larry Jeffers Race Cars, a budgeting and procurement case study with enhanced details. Let's revisit Larry Jeffers Race Cars, LJRC, through the lens of budgeting and procurement, incorporating more specific and measurable details to illustrate the concepts. Scenario 1, upgrading the dyno. LJRC aims to upgrade its aging dyno to a new model capable of handling 5,500 horsepower engines. Here's a breakdown of the project budget. Equipment cost, $280,000. This is a more powerful dyno to handle future engine upgrades. Labor cost, dismantling the old dyno and installing the new one will require 3 technicians for 2.5 days at a rate of $80/hour each. 3 technicians 2.5 days 8 hours, day $80/hour, equals $4,800. Calibration cost, a certified technician needs to calibrate the new dyno for accurate readings within a tolerance of ±0.5%. This one-time cost is $2,500, reflects higher precision calibration. Software upgrade, the new dyno requires a software upgrade, $7,000, for compatibility with LJRC's existing data acquisition system, ensuring seamless data integration. Contingency buffer, a 15% buffer is allocated for unforeseen costs, considering the complexity of the new dyno. Total budget excluding buffer 15% equals $45,900. Total project budget, $280,000. Equipment, plus $4,800. Labor, plus $2,500. Calibration, plus $7,000. Software, plus $45,900. Buffer, equals $340,200. Procurement process, request for proposal, RFP. LJRC drafts an RFP outlining the dyno specifications, horsepower capacity, data acquisition compatibility, etc., desired functionalities, remote control, automatic test cycles, and budget range, $250,000, $300,000. The RFP is sent to 5 reputable dyno manufacturers. Vendor selection. Proposals are received, and LJRC evaluates factors like price, features, warranty, minimum 2 years, after-sales support, response time within 24 hours, and lead time, must be delivered within 8 weeks. They shortlist 3 vendors and negotiate the final price, terms, and guaranteed performance specifications. Contract signing, a contract, scope of work, SO, is signed with the chosen vendor, clearly specifying the deliverables, including dyno model number, serial number, and calibration certificate, timelines, delivery date and installation timeframe, payment schedule, 50% down payment, 50% upon completion and acceptance testing, and warranty terms, coverage, repair turnaround time. Success metrics, project completion on budget. The project is considered successful if the total cost stays within the allocated budget of $340,200. Dyno performance improvement, horsepower and torque measurement accuracy should improve to within ±0.5% tolerance compared to the old dyno. This ensures reliable data for engine tuning and performance analysis. Project timeline, the project should be completed within the planned timeframe of 10 weeks, including dyno delivery, installation, calibration, and software integration testing. Scenario 2, sourcing high-performance parts for a top fuel drag car. LJRC is building a new drag-and-drive hot rod aiming for a target quarter-mile elapsed time of 6.4 seconds at 225 miles per hour. Here's how budgeting and procurement play a crucial role. Identifying requirements. LJRC engineers determine the specific performance requirements for each part category. Engine block, designed to handle 4,000 horsepower and withstand nitromethane fuel. Cylinder heads, optimized for high-flow air intake and efficient combustion at high RPMs. Fuel system, capable of delivering precise fuel metering at high pressure, for example, flow rate of 100 gallons per minute at 80 pounds per square inch. Budget allocation, a budget is allocated for each part category based on market research and supplier capabilities. Engine block, $30,000. Cylinder heads, $22,000. Fuel system, $20,000. Vendor research, the procurement team researches potential vendors who specialize in manufacturing top fuel drag racing parts. They prioritize vendors with proven history of supplying parts for cars in the P.4 second range. Documented quality control processes and certifications. Ability to provide technical support and ability to provide technical support and replacement parts quickly, within 24 hours, to minimize downtime during car assembly and testing. Price quotes. LJRC requests quotes from 3 shortlisted vendors, outlining the part specifications, desired quantities, including spares for critical components, and delivery deadlines. The quotes should also include details on material composition and manufacturing process for each part. Warranty terms, coverage period and repair turnaround time. Lead times for parts and replacement parts. Negotiation and purchase orders. Based on the quotes, LJRC negotiates pricing, lead times, and warranty terms with the chosen vendors. Here are some specific targets. Negotiate a 5% discount on the total cost by leveraging the bulk purchase of all 3 parts from a single vendor. Secure a lead time of 6 weeks for the initial parts order and 2 business days for replacement parts. Extend the standard warranty to 18 months for all parts. Purchase orders, POs. Once the agreement is finalized, LJRC issues purchase orders to the chosen vendor. The POs clearly specify part descriptions, including part numbers, quantities, and revisions, unit prices and total cost delivery deadlines, including penalties for late deliveries, payment terms, for example, net 30 days after receipt of parts, inspection and acceptance criteria, success metrics, cost efficiency, procuring parts within the allocated budget of $72,000, total budget for engine block, cylinder heads, and fuel system. This might involve negotiating further or finding cost-saving alternatives for certain parts while maintaining performance requirements. Lead time management, receiving parts on time, within 6 weeks for the initial order, to meet the project timeline for car assembly and testing. Part quality, the parts meet or exceed the performance specifications, for example, engine block withstands 4,000 horsepower, cylinder heads optimize airflow, fuel system delivers precise metering. This is verified through inspections upon receiving the parts and during initial dyno testing of the engine. Vendor performance, the chosen vendor meets the agreed upon lead times and provides technical support during the assembly and testing phase. They should also be responsive in supplying replacement parts within 24 hours if needed. By following these detailed procedures for budgeting and procurement, LJRC can ensure they acquire the high-performance parts needed for their top fuel drag car within budget, on time, and with the necessary quality and support to achieve their target race times. The importance of budget setting. A project budget is an estimate of the money needed to complete a project. It is broken down by milestones, which are important points in the project schedule. A project budget is a forecast that is reviewed and updated throughout the project lifecycle. The project budget includes costs for labor, materials, and equipment. A project budget is a communication tool used to inform stakeholders about the project. The project budget is created during the initiation phase of a project. The project manager may need to get approval for spending from stakeholders. Project budgeting is done in conjunction with project scheduling. After the costs are estimated, a project sponsor or stakeholder may need to approve the budget. Project budgeting is not a one-size-fits-all process. Project managers need to prioritize how to allocate funds within the project budget. Larry Jeffers Race Cars, the importance of budget setting. Larry Jeffers Race Cars, LJRC, prioritizes meticulous budgeting to ensure project success. Let's delve deeper into how budgeting impacts 2 of their key initiatives. Scenario 1, upgrading the engine dyno. Project goal, upgrade the aging dynamometer to a new model capable of handling 1,200 horsepower engines in anticipation of developing high-performance racing engines. Budget breakdown. Equipment cost, $250,000. Extensive research identified a dyno model exceeding initial horsepower requirements for future-proofing. Labor cost, dismantling the old dyno and installing the new one will require 3 technicians, increased due to the new dyno's complexity, for 2.5 days at a rate of $85/hour each. Adjusted labor rate reflects market changes. 3 technicians 2.5 days 8 hours, day $85/hour, equals $5,950. Calibration cost. A certified technician needs to calibrate the new dyno for accurate readings within a tolerance of ±- 0.5%. This one-time cost is increased to $2,700 to reflect the higher precision requirements for the new dyno. Software upgrade. The new dyno requires a software upgrade, $8,000, for compatibility with LJRC's existing data acquisition system, ensuring seamless data integration for precise engine performance analysis. Contingency buffer, a 12% buffer is allocated for unforeseen costs, considering the increased complexity of the new dyno. Total budget excluding buffer 12% equals $33,720. Total project budget, $250,000. Equipment, plus $5,950. Labor, plus $2,700. Calibration, plus $8,000. Software, plus $33,720. Buffer, equals $300,370. Importance of budget setting. Project feasibility assessment. The defined budget helps assess project feasibility. If initial estimates exceed available resources, LJRC can explore alternative dyno financing options or slightly adjust project scope by targeting a slightly less powerful dyno model. Stakeholder communication and approval. The budget serves as a communication tool to inform stakeholders, owners, sponsors, about the project's financial requirements. Stakeholder approval might be needed before proceeding, and the detailed budget breakdown ensures transparency. Enhanced cost control and tracking. The budget acts as a baseline for monitoring project expenses with increased granularity. LJRC can track actual costs against budgeted amounts for each expense category, for example, labor hours used versus budgeted hours, to identify variances and take corrective actions if needed. This allows for more proactive cost management. Scenario 2. Building a competitive drag-and-drive drag car. Project goal: build a drag-and-drive drag car aiming for a target quarter-mile elapsed time of 6.4 seconds at 225 miles per hour, potentially exceeding competitor performance and increasing its market value. Budget setting process. Market research. LJRC conducts in-depth market research, analyzing competitor car specifications, pricing, and recent performance data. They establish a target sales price of $220,000 for their car, considering the potential performance edge. They then estimate the maximum budget they can allocate for parts and assembly to achieve a 20% ROI. Increased target ROI reflects the potential higher selling price. Cost breakdown. Based on market research, supplier quotes, and considering performance requirements, LJRC creates a detailed budget for each car component category. Engine block internal components, $44,000, increased budget to accommodate higher horsepower engine. Transmission drivetrain, $16,400, increased budget for a more robust transmission. Suspension chassis, $13,600, increased budget for lightweight and high-performance components. Aerodynamics package, $9,600, increased budget for a custom-designed aerodynamic package for optimal downforce. Safety equipment fabrication, $8,500, adjusted budget for top-of-the-line safety equipment. Labor assembly, $6,900, adjusted budget based on estimated labor hours. Total project budget, $195,000, increased total budget to accommodate performance targets and potential ROI. Scenario 3, building a client race car, continued, cost control and monitoring. Once the project commences, the approved budget serves as a benchmark for monitoring project expenses. LJRC tracks actual costs incurred against budgeted amounts throughout the build process. This allows for identifying cost variances, early detection of cost overruns or underruns. For instance, if a critical engine component exceeds the budgeted amount by $2,500 due to unexpected input tariffs, LJRC can explore alternative engine components with similar performance specifications that fall within the budgeted amount for that category, for example, a different camshaft. Negotiate with the supplier for a better price on the originally desired component. If necessary, propose a cost-saving adjustment to the client's specifications, for example, a slightly different engine air intake system, while maintaining overall performance targets. Taking corrective actions. If cost variances arise, LJRC can take corrective actions to get the project back on track. This might involve implementing stricter cost controls on specific expense categories, like monitoring overtime hours for labor costs. Seeking sponsorships from parts manufacturers or racing fuel companies to offset material costs. Proposing a phased payment schedule to the client, where certain payments are tied to project milestones, ensuring sufficient funds are available throughout the build process. Additional considerations for effective budgeting. Market fluctuations. LJRC acknowledges that costs of parts, labor, and materials can fluctuate due to market conditions. They consider historical data and industry trends when creating budget estimates. They also build in contingency buffers to account for potential cost increases. For instance, if the cost of high-performance racing tires is projected to increase by 5% due to global rubber shortages, LJRC might factor in a 7% contingency buffer for the tire budget category to absorb this potential cost increase. Project schedule. The project budget is created with the project schedule in mind. Anticipated expenses are distributed according to the project timeline, ensuring sufficient funds are available when needed for specific project phases. For example, a larger portion of the budget might be allocated towards the earlier phase of the project to cover the cost of procuring all the necessary parts. Later phases might see a higher allocation for labor costs as the focus shifts towards car assembly and testing. Conclusion: by prioritizing budgeting throughout the project lifecycle, Larry Jeffers race cars achieve several key benefits: increased project success rates, well-defined budgets with measurable targets, for example, not exceeding a specific percentage of cost variance, enhanced project planning, resource allocation, and cost control, ultimately leading to higher project success rates. Improved financial visibility. Budgets provide transparency into project finances, fostering better communication with stakeholders, owners, sponsors, clients, and ensuring financial sustainability. Detailed variance reports can be generated to identify cost trends and areas for improvement in future projects. Data-driven decision-making. Budgets facilitate data-driven decision-making throughout the project. By analyzing cost variances and project performance, LJRC can continuously improve their budgeting practices for future endeavors. They can also use historical budget data to create more accurate estimates for future projects. In conclusion, Larry Jeffers Race Cars exemplifies how meticulous budgeting, with specific cost monitoring and corrective actions, is a cornerstone of successful project management in the fast-paced and dynamic world of motorsports. By employing these practices, LJRC can achieve their project goals while maintaining financial stability and exceeding client expectations. At what point in the project life cycle does the project manager create the project budget? A. Closing phase. B. Initiation phase. C. Planning phase. D. Execution phase. The answer is B. Initiation phase. Correct. It's important to remember the project manager may need to adjust the budget throughout the project life cycle. The project budget is created in the initiation phase of the project life cycle. This is the initial stage where the project is first defined and a high-level plan is created. The budget is a crucial element of this plan, as it helps to determine the feasibility of the project and secure necessary resources. Who creates estimates for the project budget? A. Chief Financial Officer, CFO, B. Project Manager. C. Team Representative. D. Project Sponsor. The most likely answer is B. Project Manager. Correct. The project manager also collaborates with other people on the project to create the estimates. While all the answer choices can be involved in the budgeting process, the project manager typically has the primary responsibility for creating the initial estimates for the project budget. They work with various stakeholders to gather input on costs, and use their expertise to develop a realistic and achievable budget for the project. Key components of a project budget. Key components of a project budget. Understanding stakeholder needs, knowing what stakeholders expect from the project, for example, profit, cost savings. Budgeting for surplus expenses, accounting for unexpected costs, for example, broken planters. Reviewing and reforecasting, monitoring budget and revising it as the project progresses, for example, reallocating funds from plants to marketing. Additional factors to consider. Resource cost rates, cost of resources like labor, tools, equipment, materials, and software. Reserve analysis, identifying potential risks and allocating buffer funds, contingency budget, to address them. Cost of quality, costs associated with preventing issues, prevention costs, appraising quality, appraisal costs, fixing internal defects, internal failure costs, and fixing external defects, external failure costs. Benefits of budgeting. Staying organized. Recalibrating budget as needed. Ensuring project stays on track. Overall, project budgets are estimates that can change. Reviewing and reforecasting helps manage the budget throughout the project lifecycle. What should a project manager account for when project budgeting? Select all that apply. A. Surprise expenses. B. Stakeholder needs. C. Competitor prices. D. Reforecasting throughout the project. Surprise expenses. Unexpected costs can arise throughout a project. A good budget includes a buffer to cover these unforeseen expenses. Stakeholder needs. Understanding what stakeholders expect from the project, for example, profit, cost savings, features, is crucial for allocating resources and setting realistic expectations. Reforecasting throughout the project. As the project progresses, costs may need to be adjusted based on actual expenses and project performance. Regularly reviewing and revising the budget is essential for staying on track. Competitor prices generally would not be a direct factor in budgeting a project. While being aware of competitor pricing may influence the overall project goals or scope, it wouldn't directly impact the cost of resources needed to complete your specific project. Deepening our understanding of project budget components with Larry Jeffers' race cars. Let's delve deeper into the key project budget components using Larry Jeffers' race cars, LJRC, as an example, incorporating even more specific and measurable details. 1. Understanding stakeholder needs. Scenario: LJRC is building a new Pro Street Dragon drive car for the upcoming season. The project stakeholders include team owner, Uncle Jesse, profit-driven, targeting a 15% profit margin on the car's final sale price of at least $250,000. Lead driver, Luke Duke, performance-focused, desiring a car capable of achieving a quarter-mile elapsed time of 6.4 seconds at 225 miles per hour and exceeding the performance of the main competitor's car, known to run a 6.5-second quarter-mile. Measurable details. Based on competitor analysis, LJRC estimates the car needs at least 4,200 horsepower to achieve Luke's performance goals. This translates to a minimum engine output of 1,050 horsepower per liter, HP/L, for the chosen engine block. Budget impact. LJRC allocates the budget considering both stakeholder needs. They prioritize high-performance parts to meet Luke's goals, for example, allocating $60,000 for a top-tier, lightweight racing engine with a proven track record of exceeding 1,050 horsepower/L. They keep overall costs under control to achieve Uncle Jesse's desired profit margin. This might involve negotiating with suppliers for bulk part purchases, seeking sponsorships to offset material costs, or exploring alternative materials that deliver similar performance at a lower cost. 2. Budgeting for surplus expenses. Scenario: during the engine assembly phase, a critical engine block component, connecting rod, unexpectedly fails a stress test. Replacing all 8 connecting rods with a higher-rated version to ensure engine reliability becomes necessary. Measurable details. The initial budget for the 8 connecting rods was $4,800, at $600 per rod. The higher-rated connecting rods, required to handle the increased engine stress, cost $850 each. Budget impact. LJRC has a 10% contingency buffer, $30,000, built into their overall project budget of $300,000 to cover unforeseen costs. They absorb the additional $2,800 cost, 8 rods, $350 price difference, from the contingency buffer. This ensures the project stays within budget while prioritizing engine reliability, a crucial factor for Luke's safety and achieving the desired performance. 3. Reviewing and reforecasting. Scenario: after initial test runs, the Pro Street car struggles to achieve the desired downforce levels at high speeds, impacting handling and potentially affecting Luke's safety and race times. The engineers identify the need for a custom-designed rear wing to optimize downforce. Measurable details. The initial budget didn't allocate funds for a rear wing. After testing, data shows a custom-designed rear wing, estimated at $12,000, would provide the necessary downforce increase of 500 pounds at 150 miles per hour. Budget impact. LJRC reviews the budget and analyzes spending trends. They identify potential areas for reallocation, such as reducing material costs for certain car parts, for example, opting for a different, less expensive aluminum alloy for the interior roll cage without compromising safety standards, or negotiating extended payment terms with suppliers. By finding $8,000 in savings, they can reduce their reliance on the contingency buffer while still allocating $4,000 from the buffer to cover the remaining cost of the rear wing. This demonstrates budgetary forecasting to maintain performance and safety targets while optimizing resource allocation. Additional factors. Resource cost rates. LJRC meticulously tracks labor costs, for example, $85 ANBUA per mechanic for engine assembly, $70 ANBUA for fabrication work, and material costs, for example, $550 per high-performance racing tire, $220 per custom fabricated exhaust system component, to ensure accurate cost estimates for future projects. Reserve analysis. LJRC anticipates potential risks like parts delays due to supply chain disruptions or unexpected component failures during the high-stress racing environment. They allocate reserve buffer of 7.5% of the total project budget, $22,500, to mitigate these risks and cover unforeseen expenses. Cost of quality. LJRC prioritizes quality control throughout the build process to minimize rework costs. They invest in preventative measures, for example, using specialized tools and employing non-destructive testing methods to evaluate components, to avoid potential internal failures, for example, faulty welds or leaks in the fuel system, that would be expensive to fix and could endanger Luke during races. Additionally, LJRC utilizes process inspections, regularly inspecting welds, machining tolerances, and assembly procedures throughout the build process helps identify and rectify potential issues early, before they snowball into major rework or safety hazards. Supplier quality management. LJRC partners with reputable suppliers who prioritize quality control in their manufacturing processes. This reduces the risk of receiving faulty components that would require rework or replacement. Training and certification. Investing in training and certifications for mechanics and technicians ensures they possess the necessary skills and knowledge to perform their jobs effectively and identify potential quality issues. By implementing these preventative measures, LJRC minimizes the cost of quality associated with rework and ensures they deliver a reliable, high-performance car to Uncle Jesse and Luke. This focus on quality control allows LJRC to achieve their project goals within budget while prioritizing safety and performance. Project Budgeting 101. Project Budgeting 101 Summary. What is a project budget? An estimate of the monetary resources needed to achieve project goals. Created in initiation and planning phases, reviewed throughout the project lifecycle. A tool for communication, tracking progress, cost control, and financial baseline. Project budgeting best practices. Reference historical data, learn from past projects. Utilize your team, get extra sets of eyes on your budget. Time phase your budget, allocate costs based on the project timeline. Check your work, ensure accuracy before seeking approval. Categorize costs. Direct costs are necessary for project completion, for example, salaries, materials. Indirect costs support the project team, for example, utilities, insurance. Baseline budget, the initial approved project cost estimate. Used to compare actual performance and make informed adjustments. Monitoring and adjustments, continuously monitor your budget and make changes as needed. Budget updates may require reapproval. Rebaseline your budget for significant scope changes. Reserve analysis, account for buffer funds, contingency budget, for unexpected costs. Consider cost of quality, costs associated with delivering a quality product, service, for example, fixing defects, rework. Key takeaways. Project budgeting involves multiple parties and documents. Best practices can help simplify the process. Utilize historical data, time phasing, and teamwork. Capture all costs, direct, indirect. Baseline your budget for tracking. Deepening our understanding of project budgeting with Larry Jeffers race cars. Building on the previous examples, let's explore project budgeting with Larry Jeffers race cars, LJRC, through even more detailed fictional scenarios incorporating richer details and measurable numerical specifics. 1. Time-phased budgeting and resource allocation with sponsor integration. Scenario: LJRC is building a new top fuel dragster for the upcoming season. The project has a tight 8-month timeline with distinct phases: design, 1.5 months, procurement, 1 month, fabrication, 3 months, assembly, 1.5 months, and testing, 1 month. To secure funding, LJRC partners with Apex Lubricants, a major oil company, who agrees to sponsor the car in exchange for prominent branding and logo placement. Measurable details: LJRC estimates the total project budget to be $400,000. The sponsor, Apex Lubricants, contributes $150,000, which is directly allocated to material costs for high-performance engine components exceeding original specifications. Time-phased budgeting is crucial for managing this project. Design requires 3 engineers for 30 days each at $135 a day, totaling $12,150. Labor. Cutting-edge design software licenses cost $3,850. Materials. Procurement focuses on securing high-quality parts while staying within budget. LJRC leverages their supplier network and negotiates bulk discounts, saving an estimated 5% on engine components compared to initial quotes. Fabrication involves a team of 4 fabricators for 60 days each at $110 a day, totaling $26,400. Labor. Material costs for chrome molybdenum steel tubing, a top-of-the-line roll cage, and specialized welding consumables amount to $170,000. Assembly requires 3 mechanics for 45 days each at $90 a day, totaling $121,500. Labor. The upgraded engine, high-performance transmission, and lightweight drivetrain components cost $190,000. Materials, due to the Apex Lubricants sponsorship. Testing, needs 2 test drivers for 15 days each at $175 a day, totaling $5,250. Labor. High-octane racing fuel, advanced telemetry equipment, and specialized lubricants provided by Apex Lubricants cost $13,250. Materials. Budget impact. Time-phased budgeting allows LJRC to strategically allocate resources throughout the project. Sponsor funds from Apex Lubricants offset the cost of high-performance engine components, enabling LJRC to exceed their initial performance targets. Procurement efforts focus on cost savings in other areas to stay within budget. This approach ensures efficient resource allocation while maximizing the value of the sponsor partnership. 2. Contingency buffer, risk management, and dynamic adjustments. Scenario. During the fabrication phase, an unexpected heatwave disrupts the workshop's climate control system, impacting the quality of welds on critical chassis components. Remediation involves re-welding affected areas, extending the fabrication timeline by 1 week. Measurable details. The heatwave adds an additional 7 days of labor for 2 fabricators at $110 a day each, totaling $1,540 in extra costs. To expedite the rework, LJRC brings in a temporary welder for 3 days at a premium rate of $150 a day, adding $450 to the cost. Budget impact. LJRC's 10% contingency buffer, $40,000, absorbs the $1,990 in unexpected costs associated with the heat wave. However, the extended fabrication timeline pushes back the assembly phase by a week. To stay on track, LJRC overlaps some assembly tasks with the final stages of fabrication, requiring creative scheduling and coordination between teams. This minimizes the overall project delay. 3. Cost of quality and proactive maintenance. Scenario. During a routine engine dyno test, abnormal vibration readings indicate a potential imbalance in the crankshaft assembly. Early detection prevents a catastrophic engine failure at high speeds on the racetrack. Measurable details. Investigating the vibration issue requires disassembling the crankshaft assembly, performing a thorough balance check, and potentially replacing minor components for optimal balance. This preventative maintenance adds 1.5 days of labor for a mechanic at $90 a day, totaling $135 in additional costs. Budget impact. LJRC prioritizes preventative measures and proactive maintenance throughout the build process. Addressing the crankshaft imbalance early on avoids a potential engine failure that could cost upwards of $20,000 in repairs. The $135 spent on investigating and rectifying the crankshaft imbalance is a small price to pay compared to the potential consequences of an engine failure. This proactive approach exemplifies LJRC's commitment to the cost of quality, ensuring they deliver a reliable and competitive dragster for the upcoming season. Long-term implications. By effectively utilizing project budgeting practices throughout the top fuel dragster project, LJRC achieves several key successes, stays within budget, despite unforeseen circumstances like the heatwave. LJRC's contingency buffer and resource management strategies ensure they stay within the overall project budget of $400,000. Exceeds performance goals. The sponsorship from Apex Lubricants allows LJRC to incorporate high-performance engine components, exceeding their initial performance targets and potentially increasing their winning chances during the race season. Build strong partner relationships. Effective communication and budget management during the sponsorship with Apex Lubricants strengthens their partnership. LJRC delivers value by showcasing the Apex Lubricants brand on a high-performance race car, while Apex Lubricants contributes to LJRC's success. Develops a culture of quality. LJRC's focus on preventative measures and cost of quality throughout the project minimizes rework and potential race day failures. This commitment to quality establishes a strong foundation for their racing program and future project endeavors. These successes demonstrate how Larry Jeffers' race cars leverages project budgeting to achieve their goals and maintain a competitive edge in the world of drag racing. By strategically allocating resources, managing risks, and prioritizing quality, LJRC sets themselves up for project success while building a reputation for excellence.